Thank you, Blanche. And let me pull up a screen or my slides. I've prepared some slides here for us. And there we go. And hopefully you can all see it fine. All right, so I'm going to talk about a story about our city. And it's going to center, of course, on the Livermore Laboratory. And after about 8 years of research, all of that work came together and it's been published now into a book, which I call From Berkeley to Berlin. Now notice there is no word Livermore in the title, and I know that, but once I finish this story, hopefully you'll understand where the title came from. But I'm going to emphasize how the amazing historical things that happened here in Livermore during the period of the 1950s. All right. Now, to understand a lot of the things that happened in our beautiful valley here, you actually need to also understand what was happening in the city of Berkeley. And in 1928, actually, Robert Sproul becomes the president of the University of California at Berkeley. And he wants to take the UC Berkeley from being a backwater of scientific research and make it a world center. And part of that plan, he recruits a physicist by the name of Ernest Orlando Lawrence, who at the time was an assistant professor of physics at Yale University. Lawrence comes out to Berkeley, and within a year or two, he shows that Sproul's instincts were quite correct, and Lawrence invents a machine which will become known as the cyclotron. And it's the modern day, it's the grandmother of these modern super collider machines, which are now in Geneva, at Fermi Lab in Chicago and that. But this was the beginning of that type of those types of machines. And for it, he will win the Nobel Prize. Now in 1931, Lawrence is building bigger and bigger cyclotrons until he's coming up with what was a 27-inch cyclotron, and he needed someplace to put it. And Sproul gave him an old engineering building at the Berkeley campus. And Lawrence moved into it, and with it, he decided to create a laboratory. And originally he called it the Penetrating Radiation Laboratory, but it soon became known as University of California Radiation Lab. But everybody called it simply the Rad Lab. And Lawrence's leadership and his just charisma attracted the leading experimentalists in the nation. And they start flocking into Berkeley to work on Lawrence's cyclotrons inside his lab, inside the Rad Lab. To give you an idea of how Lawrence's charisma could be so infectious, 5 of those individuals that came to work for him would go on and win the Nobel Prize. So this truly, Berkeley became this world center of nuclear physics. And things were going along swimmingly until actually December 1938, when in a chemistry laboratory in Berlin, Germany, a man named Otto Hahn made a discovery, which later would be shown to be nuclear fission. And in that discovery, he working with a really brilliant physicist, a Jewish woman, well, actually she was Jewish Austrian woman by the name of Lisa Meitner, who co-wrote a paper with her nephew. And with it, she explained what nuclear fission was. And they did some calculations and discovered that nuclear fission was 1 million times more powerful than a high explosive detonation, 1 million times more powerful than dynamite or TNT. And with that, when they wrote the publication and it went out, that created a storm of interest within the physics community, including with Lawrence. And Lawrence and his physicist at the Rad Lab started exploring that. But then a few months later, another paper was written, one by the great Danish physicist Niels Bohr, the so-called father of the atom. And he's working with an American physicist by the name of John Wheeler. And the two of them in their paper, and they wrote, this is just a few months after this discovery. So it was amazing how fast this was. But they announced that the fission, the nuclear fission that Otto Hahn had observed in his chemistry laboratory in Berlin was really due to a single isotope of uranium. What happened was Hahn had put a aluminum foil basically inside chamber, and then he inundated them with particles called neutrons. And that's when he discovered all this energy that was coming out. But what Wheeler and Bohr said was that it was not all of the atoms in the foil that were creating this fission. It was just one isotope of it. Now, an isotope, for a second, atoms are identified as elements by their electric charge, and that's given by the number of protons inside the nucleus. And so all fluorine atoms have 9 protons. All hydrogen atoms have 1 proton. Helium has 2 protons. So that establishes the element. But what was discovered in the 1930s is that a single element, the nucleus could have varying numbers of neutrons. So you could have, like with hydrogen, they discovered the basic hydrogen was simply a proton. But then there was another isotope, they're called isotopes of hydrogen, which became known as deuterium. And that had 1 proton and 1 neutron. And then later, another isotope was discovered, which had 1 proton and 2 neutrons. That became known as tritium. So these isotopes, each element of the periodic table pretty much have isotopes, and uranium as well. And in 1935, a isotope of uranium, uranium-235, was discovered. Uranium has 92 neutrons. And so the predominant isotope of uranium is called uranium-238. I'll let you do the mathematics. You subtract 92 from 238, that's how many neutrons it has. But this new isotope, uranium-235, had 3 less neutrons. And what Wheeler and Bohr had written in their paper was, it was uranium-235 that did all the fissioning. So what Lawrence was concerned about was he understood, German physicists were not stupid. They understood, they suddenly, a discovery had been made that if it was converted into a weapon, would be 1,000,000 times more powerful than any of the weapons known at the time, any TNT or dynamite bombs. You'd have something that's 1,000,000 times more powerful and destructive. And it was discovered in Nazi Germany. Now, Hitler was the chancellor of Germany at the time. And so Lawrence and others were extremely aware that it would be a disaster if Hitler could develop that knowledge into a weapon and into the atomic bomb. And so Lawrence then attempted to get the US government aware that there was a threat, a huge threat steamrolling towards our country. And he went to Washington. He met with a man named Vannevar Bush, who today we would call the president's scientific advisor. But anyway, at the time, Bush was a very influential, he was an engineer, but he had the president's ear. And he tried to convince Bush that the nation needed to start an atomic program in order to establish an atomic bomb before Adolf Hitler could get his hands on one. And then Lawrence also told Bush that he had made an invention. He thought about this, and he figured out a way that he could separate uranium-235 from uranium-238. And the machine he invented was called the Calutron, which was short for California University-tron. And they had worked on it at the RAD lab, and they actually got it working. They had already actually enriched means to separate out the uranium-235 4 times greater than natural uranium. And so it was showing to work, and he was trying to convince Bush to go ahead and start this program. Now, I won't go through all of the stuff that went on, but Bush did not want to do it. He didn't think it was possible to do, and there was a hemming and hawing. And you can read my book if you want to get the exciting story of how this all occurred. But anyway, this slowly worked on, but eventually Bush did accept that we could do it. You could actually make an atomic bomb. And then he started what became known as the Manhattan Project. And with that, they decided to build a plant. They had discovered this site in Tennessee called Oak Ridge, which had plenty of electricity. It had silt-free water in the Clinch River going by. And they created a plant called the Y-12 plant. And in the Y-12 plant, they put in these calutrons. These were massive machines, which required a lot of work. And it took a huge amount of effort to get them to operate and to get going. But in fact, those machines did enrich the uranium, and the fuel that was used to make the first, the Hiroshima bomb, actually came from those machines. And the picture in the lower right, it turns out most of the operators were women, young women. I don't mean to be sexist here, but it turned out that they found out the women were better operators than men. The first the first crew were male operators, and things did not work very well. And when they went around on a second time, Lawrence had all the machines taken apart, rebuilt, put together. But this time they recruited many more women, and that worked. And there you see them right during World War II. I think, and Janet Beard has written a book, and there was another book. But anyway, the Atomic City Girls, I think, were the titles of those books. That's what you're looking at, and that's what they were doing. They were actually running the calutrons to enrich the uranium. In the meantime, back at the RAD lab, another physicist by the name of Edwin McMillan, working for Lawrence, he did some more experiments like Otto Hahn had been doing in Berlin, and in it he discovered a new element, which he called neptunium, because it was the next higher element in the periodic table. Uranium is named after the planet Uranus. And so following that planetary scheme, McMillan called his next element they discovered neptunium, which is named after the planet Neptune. And then McMillan went off to Cambridge, Massachusetts to work on another laboratory project that Lawrence had started up that was developing radar for World War II. And while he was gone, a chemist working down the hallway from McMillan, his name was Glenn Seaborg, sent a Western Union telegram to McMillan and said, "Ed, do you mind if I pick up your experiments where you left off?" And McMillan said, "Fine." And Seaborg, anyway, he went back. He separated out the neptunium. Seaborg was a phenomenally great chemist. He separated out the neptunium, and he discovered the neptunium also decayed away into the next higher element in the periodic table. And following that planetary scheme, the next planet is Pluto. So he called the new element plutonium. And then they quickly did some experiments, and they found out, sure enough, that plutonium, which had a half-life of 24,000 years, that means your sample, half of your sample would still remain after 24,000 years. So it was very stable. But it was an alternate way of making nuclear fission bombs. Other than uranium-235, you can simply use the plutonium that is created by taking just natural uranium, hitting them with neutrons. The neutrons make it into uranium-239, and eventually that will decay into plutonium. And then Seaborg also then invented a chemical process you could use to separate out the plutonium from the spent fuel that was in these reactors, or as they called them at the time, nuclear piles. Now, at the time they started the Manhattan Project, General Groves, Dick Groves, was placed in head of it. And he flew out to Berkeley, and he asked Lawrence to create a laboratory to design the bomb. And Lawrence told General Groves he had his arms full trying to handle the Y-12 plant, trying to get all the operations at Y-12 running. So he suggested he use the theoretical physicist in the RAD lab was a man named J. Robert Oppenheimer. And he suggested he talk to Oppenheimer instead. And Groves did, he accepted Oppenheimer to become the next, or to create a laboratory to design the atom bomb. And of course, Oppenheimer then created what we now know as Los Alamos Laboratory. Now, when Oppenheimer created the laboratory, things are going, two of the physicists that arrived were Enrico Fermi and Edward Teller. Enrico Fermi, a Nobel laureate, was one of the greatest physicists of the 20th century. Edward Teller, Hungarian-born physicist and a really good friend of Fermi's. They had met back in Rome, Italy. But anyway, they came together, and Fermi had an idea that, is it possible to use an atomic bomb and the heat from that to initiate fusion reactions, which would create even more energy, and therefore you can make an even stronger or bigger bomb? And Fermi had asked Teller this, and Teller worked on that idea, and eventually he came up with a solution. He came back to Fermi and says, "I think it can be done." And he called this new invention the super. And so, if you will, the super is a bomb in which you use an atomic explosion to set up high temperatures, and the high temperatures are used to fuse atoms together. These atoms tend to be hydrogen atoms, and so later the super would later be called the hydrogen bomb. And another term we all use in physics is these are what we call thermonuclear weapons, because these weapons have to use high energy, which in physics, energy and temperature can be related together. So a physicist might say these were high temperature reactions, and therefore the name thermonuclear reactions. And so the birth of this idea. And so during the Manhattan Project at Los Alamos, Teller was the head of a small group, and they tried to put together the super. They did not make much progress. at all. By the end of the war, the Los Alamos had designed and developed 2 weapons, one which used plutonium and one which used uranium-235. And Oppenheimer went to tell her and said, we don't need the super anymore. So he just squashed the idea, killed it, and that stopped. And so Teller went back to Chicago with Fermi, then spent the next years studying that until interest grew because in 1949, in August of 1949, the Russians detonated an atomic bomb in the country of Kazakhstan. It was a test site called Semipalatinsk, for those of you interested in details. But anyway, the Russians detonated this atomic bomb, and now Russia was a nuclear power. And once again, it got Lawrence's attention because he knew the Russians would also not stop with an atomic bomb. They would try to make a hydrogen bomb as well. Hydrogen bombs being much more powerful. And so just as his passion grew that he didn't want to see Hitler be in sole possession of an atomic bomb, he did not want Stalin, who was then the premier of the Soviet Union, to have his hands on a hydrogen bomb and be alone in the world having such a weapon. It would be a disaster. And so Lawrence decided he needed to go back to Washington and see if he can get and wake up the government that we have another possible threat steamrolling towards us. And before he goes down to Los Alamos. He visits with Teller had since come back to Los Alamos under a contract to keep on trying to develop the super. And Lawrence goes and visits that group. And while he's there, he's told the program could badly use the element tritium. Tritium, again, is an isotope of hydrogen. It's a proton with 2 neutrons. And there is no natural tritium in the world because tritium is radioactive and it decays away. Half of it decays away in 12 years. So there is practically no tritium in the world, but it was needed to make this super weapon work. So Lawrence then goes back to Berkeley and tries to figure out now how is he going to make tritium for the program. He first conjectures making a nuclear reactor up in Sassoon Bay, a heavy water reactor, but that gets squashed. That idea gets squashed. And then he thinks about using an accelerator to create tritium. They do some calculations, and the idea has a lot of merit. So he goes back to the Atomic Energy Commission, and he asks for money to create a huge accelerator to create tritium, and he gets the money. Then he says, now he needs a place to put this big thing. It's a huge construction. It's much too big for Berkeley. And so he goes back to the Pentagon, and he asks, well, where can I put this thing? And they said, well, take any of the mothballed military sites in the Bay Area. You can have any of them. And so Lawrence, along with his deputy, Louis Alvarez, they go on a trip, and they go to Camp Parks in Dublin. They look it over, the Army post there. And then they show up at the Livermore Naval Air Station, and they're looking around. There's all the barracks are there. There's a mile-long runway in the middle of it. There's a square mile of territory. But then the Navy also built an Olympic-sized swimming pool, an indoor swimming pool for training Navy pilots on survival. And according to Alvarez, Lawrence and Alvarez walk in, they look at the indoor swimming pool. Alvarez then turns around and says, Louis, we found a home. And so if you want to know why the laboratory showed up in Livermore, it's all about the swimming pool. That's what did it. And so they move out there, and then you can see the picture on the lower right. That's where they're constructing this accelerator, which Lawrence called the Mass Test Accelerator. And it's a huge affair, as you can see. It was designed and built by a famous physicist. His name is Wolfgang Panofsky. Panofsky became the first head of the Stanford Linear Accelerator Center at Stanford. Same individual. But there you have the first presence of the RAD lab now inside Livermore. In modern days, inside the laboratory, that structure is now called Building 431. At the same time now, Lawrence offered to help Los Alamos with conducting nuclear tests that might also further our knowledge of stuff. And Los Alamos responded by saying, we could use physicists to build diagnostics to see if we could see thermonuclear reactions. And Lawrence went to one of his physicists who had worked out at Y-12 during the war, and his name is Herb York. And York took over a project which they called the measurements team, and they started building diagnostic equipment. These are sensors and detectors for nuclear testing. And again, they needed a lot of room. And so they moved out to Livermore too. And they occupied a barracks across the street from the MTA. And all of that effort now, the RAD labs Rad Labs efforts going on in Livermore were called Project Whitney. I went back a little bit, and looking back at that Naval Air Station, it was quite an enterprise. There are a few thousand men and women out here. The women were waves, and they were mechanics, they were administrators, they were pilots. They were very much as much involved with the Naval Air Station as all the men were. And so there's quite a community out here. You can see that's a Reveille formation on the left, where some of the naval personnel stationed at Livermore forming up in the morning. And then a collage of photographs on the right are just different events they had. As you can see, they had lots of dances, but then they had a lot of stuff going on. And there's a very, very active base. One of the things maybe some people don't know, but the actor Robert Taylor, he came out to Livermore and he got his Navy flying wings out here at Livermore, and this is where he was trained to be a naval pilot. All right, but back to the other story. Meanwhile, there's concern going on, frankly, that at Los Alamos, the activities were not going. There was not a lot of passion at Los Alamos to do thermonuclear research. The main reason, in my opinion, is Oppenheimer himself. He had this big change of heart. He decided that all of this work was immoral, even though he was extremely aggressive during the war. Then after the war, he became extremely non-aggressive. He was a very passionate person, if you will, no matter what direction he went into. And so in Washington, there were many people getting a little bit nervous that the Russians were going to come up with a hydrogen bomb before the United States could. And one of the AEC commissioners, the AEC, by the way, is the Atomic Energy Commission. That was a commission created in 1946 to handle nuclear weapons research in the United States. And one of the commissioners in the AEC came out here. His name was Tom Murray. And he met with Lawrence, and he said, Lawrence, we need another laboratory to do thermonuclear research, or the Russians are going to be all by themselves possessing a hydrogen bomb. Lawrence agreed with him, and he agreed to create a second laboratory, just as much as he had agreed to help create the first laboratory, which is why both Los Alamos and Livermore in those days all worked under contracts from the University of California. And it was Lawrence working with the regents of the university to get the government contracts. And so on the second day of September, 1952, the laboratory in Livermore opened up under the new name University of California Radiation Lab. That's the RAD lab. And then this was the Livermore site. Lawrence was the director out here. This is simply part of the RAD lab, but he appointed Herb York to run operations in Livermore. So in modern lingo, York would have been an associate director of the RAD lab running operations in Livermore. He had other people like Edmund McMillan running operations back in Berkeley. All right, so now you have a new laboratory starting up here, and the initial conditions were not all that great. Practically all of the initial recruits that came out here came right out of the RAD lab, and so they were commuting in from Berkeley. And half of them, within a short while, half of them moved out of Berkeley, and there were contractors and developers, of course, seeing the new influx of people who started building what I'd call cardboard duplexes, if you will, all along East Avenue, which was transforming itself from a country road out of Livermore, heading east out of Livermore, and it became a more major highway because it connected Livermore now with this bigger facility, the laboratory. And so some of them were moving into these duplexes along Livermore Avenue, and the rent was $80 a month. And the contrast between Berkeley and Livermore, you might imagine, if they were all used to the more urban environment of Berkeley, it was a bit of a contrast when they came into Livermore. And if it was like my first day in Livermore, when I went down First Street, I remember seeing 4 antique stores and three saloons, kind of thing. And I think it's pretty much what it looked like back then too. So it was a very Western kind of culture, cowboy kind of culture, rather than the Berkeley kind of culture. The other thing was there were no air conditioners at the lab. The AEC bureaucrats said thought it was too costly for the taxpayer to be paying for air conditioners. That didn't get fixed for a couple of years. Similarly, there was not much in the way of heaters. There was not even a big hall where people could meet. And so Edward Teller, they borrowed the Livermore High School auditorium, and Edward Teller went in there and he gave lectures on atom bombs to physicists. using the Livermore High School auditorium. It was, I guess they assumed they cleared out the people from around there, and he gave his lectures there. So everything was kind of improvisation to get things going, but they needed to get things going. And so they, Herb York, who's running operations out there, decides we need to have something tested the next year in 1953. And they're going to put that together. Now, the laboratory, when it's organized, one of the things they benefited, or what one of the legacies of Lawrence was his management system, or the way he led things, the way he led the RAD lab. And you had your standard organization. You had a physics division, engineering division, chemistry division, plant engineering, administrative divisions. But if a problem came up or you challenge, they would create what they called a program, and then they would appoint a program leader. And then the program leader would select individuals from each of the parent divisions and put all of these individuals together into a program. So the environment was, you had a highly eclectic group of people with very different types of backgrounds. Some are chemists, some are mechanical engineers, some electrical engineers, and physicists, both theoretical and experimental physicists. And this became a very, very innovative type of environment. And you're going to see how that would have profound influence on the way the laboratory would progress in its early years. Another thing that happened is one of Lawrence's close friends, you'll know more about it if you read my book, but his name is David Griggs. They had met when Lawrence had opened up the MIT radiation laboratory to research radar. Anyway, Griggs by this time had become the head of the physics department at RAND Corporation, which is a think tank that had been created by the Air Force down in Santa Monica, California. And so Griggs sent a military analyst up to Livermore to see what's going on, figure out what's going on, because these guys are doing the political analysis for the Air Force. These analysts that came up here, and frankly, many of them just lived here, included some of the best political minds at RAND. Bernard Brodie was early, so he wrote a book right after World War II called The Absolute Weapon, which became kind of a Bible for deterrence theory that came out. William Kaufman, you see his picture on the lower right, was a brilliant disciple of Brodie, but then Kaufman developed his own ideas. And later, his ideas would evolve into becoming national strategy. He was also, later he would become the head of the political science department at MIT. But he came out, he took up residence up here. Herman Kahn, the gentleman on the left with his thumb sticking up, was a physicist, but he was a military analyst. He had an office up here. I later found out it was right next door to a physicist named Mike May, who's another character in my book, a big character in my book. You probably don't know who Herman Kahn is, but he'd written a book on thermonuclear war, and he introduced the concept of doomsday machines and doomsday weapons. And later, Hollywood made a movie called Dr. Strangelove, and the Herman Kahn, it was a caricature of Herman Kahn. So you're looking at the real Dr. Strangelove there, the gentleman on the left who was living here in Livermore. So we had our own Dr. Strangelove right here. Albert Wohlstetter, very, very talented. Him and his wife Roberta were very, very talented military analysts. They later would be awarded the national prizes by President Reagan. The Latter brothers, Dick and Al Latter, also all these were very, very prominent military analysts out of RAND. In addition to that, we had phenomenal scientists also gathering here at Livermore. John von Neumann is a Hungarian-born mathematician, probably the greatest mathematician of the 20th century. Besides inventing game theory, this, that, and the other thing, he basically invented the modern digital computer. All of our computers can go back to von Neumann. Now, I know some of you saying, wait a minute, I saw the movie, The Imitation Game, where Alan Turing was that brilliant mathematician who broke the secret German code during World War II, and he invented that computer and they used it. And that's all quite true. But it was John von Neumann who brought Alan Turing here to the United States and had him get his PhD at Princeton and working. So Turing and von Neumann complemented each other. But von Neumann, anyway, he was a big computer whiz, was living here practically. David Griggs, I already mentioned, he was a great geophysicist. Eugen Wigner was a Nobel laureate. Emil Konopatinsky was a very famous nuclear physicist from the University of Chicago. Gregory Bright is a Russian-born nuclear physicist, one of the greatest physicists in the world at the time. And all of these individuals are coming and were regularly working among the young 20-something-year-olds here at Livermore. So what I'm trying to say is Livermore became an epicenter, became quite a center of intellectual power within the entire United States, and they were all centered right here in Livermore, working at that laboratory. Now, a little bit more on two of these individuals. There's John von Neumann, the picture of John von Neumann in the middle. And he convinced the laboratory management, if they wanted to accomplish anything, they needed to have computers and use computer analysis. And so right away, right off the bat, the laboratory bought an IBM CPC machines. That's a card programmable calculator, I think is called. And it read computer cards 1 per second going through it. Now, these were very early machines. And then a couple of months later, the UNIVAC, the universal calculator computer arrived at Livermore. We had the number 5 one, and boom. And then von Neumann worked on all the physicists and really cajoled them to write computer codes and do their analysis by using computer enhancement. And I noticed when I arrived here, there was what I call a computer culture grew up here, in which everything we did, first you had to model it, understand what you were doing, make it work on a computer before you even began to work on an experiment. My mentor, my first group leader here, was a phenomenal physicist by the name of George Mention. And in fact, George's son, John, may be listening in. If he is, you should be proud of your father. George was a brilliant man, and he lectured me on the culture of Livermore. Said, Tom, here we are not like the Tom Edison laboratory. We're not going to take 1,000 light bulbs to figure out what's the best filament. Here we understand the physics of it. We will calculate what the best filament should be, and then we'll put it together, and then we'll model it on a computer, and only then will we test it. And that's the kind of culture that grew up here, the great dependence on computers. As a result, Livermore became a center for computer science. And of course, as you know, maybe don't know it, we've had some of the world's fastest, biggest computers here at Livermore. In fact, today, I think now, I don't know if the name of the latest, I think Sequoia is one of our most recent computers. It's huge. It's so big, it generates enough heat that it needs 5 water towers just to absorb the heat generated by it. And when it's operating, it competes with the entire city for the use of electricity. These are phenomenal machines, but they represent military power of the United States in this. And they're all legacies of this Johnny von Neumann that spent a lot of time here, quite a bit of his time in the 1950s. Another big icon that basically worked out here in Livermore is John Wheeler. There he is again. I mentioned him earlier. He had written that paper with Niels Bohr in isolating uranium-235 was the key element for nuclear fission. And that's Wheeler again. If you don't know who he is, he was probably one of the greatest American physicists of the 20th century. He coined a phrase called a black hole to describe a star so massive that even light doesn't escape from it. So that phrase, anyway, if you use that phrase, John Wheeler is the one who invented it, and that he was out here. He would sit down with physicists, work with them. He had created this program called Matterhorn B, which supported Los Alamos to create the first hydrogen bomb. And he and some of his physicists came out here to Livermore and were working on a daily basis with our own physicists and helping them to understand the physics associated with thermonuclear physics. All right. Now, we had to start. And so the laboratory in 1953 conducts 2 nuclear tests, 2 quick nuclear tests. The names of the tests are Ruth and Ray. Ruth is named after Ruth Brockett, who is Edward Teller's executive secretary. Ray is named after Ray Doofus, who was Jim Bell's executive secretary. Jim Bell was the head of engineering at the laboratory. Both experiments fizzled, that is, they were complete failures. And the thing was, Edward Teller had control over nuclear weapons designs because he was the one person at the laboratory who had experience from Los Alamos. And Edward was very much like the idea of this using a hydride, which is a mixture of uranium with the hydrogen isotope deuterium. So it was a mixture of uranium and deuterium together. And I don't think I want to go through this again. You can read my book if you want more discussion of why they were not such a good idea. You can read it, but they were fizzles. They failed miserably. And so the first 2 tests of the laboratory failed, and people were questioning what happened. Was it a wise thing to create this laboratory? But then the next year, in 1954, the laboratory went out once again, this time to test a complete thermonuclear weapon. Again, Edward Teller ran the show, it was his idea, and it also was a complete, absolute failure. And people in Washington were calling to shut down the laboratory out here, that this place was a joke, it was a waste of government money. Isidore Rabi was a leading physicist within the Atomic Energy Commission. He outright called for the laboratory to be shut down. Meanwhile, the director at Los Alamos, that's LASAL is an acronym for Los Alamos Scientific Laboratory. His name is Norris Bradbury. He said the laboratory either should be closed or it should be going back to just simply supporting Los Alamos building diagnostics, because these people clearly don't know what they're doing. Now, right in the middle of this, which is the nadir, I mean, it's looking bad for the lab. A lot of people in Washington calling to shut it down. 2 weeks after that test, in 1954, Robert Oppenheimer is called for his clearance. President Eisenhower withdraws his clearance, and then Oppenheimer demands a hearing so he can get his clearance back. And they have this hearing. And the head of the Atomic Energy Commission at the time, Louis Strauss, wants to prove that Oppenheimer is a Soviet spy. He probably is not, but he wants to prove it. And in order to prove it, he wants to show how much Oppenheimer had tried to stymie thermonuclear research going on. And in order to do that, you had to go to where were the people who were most aggressive and passionate about pursuing thermonuclear research. And that, of course, was at Livermore and at Berkeley and Livermore. And so the main character witnesses against Oppenheimer at his hearing were Ernest Lawrence, Louis Alvarez, Edward Teller, and there were others from Berkeley. And for that performance, especially after Edward Teller's performance, it was put on national TV. It was shown in newsreels at movie theaters. Teller and the rest of the Livermore crowd were ostracized by the entire physics community of America. In fact, I interviewed physicists at Livermore who had worked here in the 50s, and I asked them about those days, and they said, Tom, the first time I even heard the word Livermore was when I was in graduate school, and I was asked to sign a petition condemning the place. So it really was an idea. There was a lot of stress here that this place was going to shut down because we had 3 successive tests, 3 absolute failures. And the stress was so great that Edward Teller and Ernest Lawrence came down with attacks of colitis. It's an intestinal sickness, which is really debilitating, and they were both hospitalized. And so the leadership of the laboratory was now in the hospital, and Herb York came down with a case of valley fever. And so he ends up gets bedridden. And so the leadership of the weapons program fell on the hands of those two gentlemen. The one on the left is Johnny Foster. The one on the right is Harold Brown. These 2 gentlemen are group leaders. Johnny Foster runs the group that develops the atomic bombs that are going to drive the other part of the thermonuclear weapon. This is what's called the secondary, and that's Harold Brown's group. So these 2 gentlemen, they get together and they write a document and they hand it out to the scientists and the engineers at the laboratory, announcing we're going to abandon Edward Teller's plans. We're going to come up with our own way of doing things, in which they do. And so I call these guys upstarts in the sense that they picked up the same passionate baton that Ernest Lawrence had carried during World War II to get the country awake to the threat being posed by Hitler having an atomic bomb. And these upstarts were the same ones now that are carrying that same baton to wake up the government about the threat that might be coming from the Soviet Union. So the 2 of them get together now, and it's now going to be 1955, it's the next year, and they both better come up with something that works. And truth of their nature, they both come up with extremely exotic, brand new ideas, not the same old, if you will. They came up with brand new ideas. Johnny Foster led a group called the Hectaton Group, and it was very radical. They called it the Clio, and they put it together. And as they were developing it, it was small. And one of the things they were worried about is when they finally had to put the thing together on a tower to be tested in Nevada, the hands of the technician putting it together, putting the screws in, neutrons may bounce off his hands, go back into the device, and it could go critical because it was that close. And so Myron Knapp was the engineer responsible for assembling this thing, and he came up with an idea how to test that. So he took the Clio, had it in 2 parts, and he came up with a system where on conveyor belts, where you could unite the thing remotely on these conveyor belts. And to mimic the hands of a technician, he went down to Kelly's Butcher Shop, which is across the street from the donut wheel during the day. And he bought 10 pounds of short ribs, and he wrapped the short ribs around each half of the Clio. And so then they allowed the Clio to be assembled remotely on that conveyor belt, and it stayed subcritical, and they said, good to go. So they put it together. They actually assembled it in 2 luggage racks, Samsonite luggage racks, reinforced. And then they brought in a guy. There was a summer intern from San Jose State University. His name is Tommy. He has a Polish last name. I apologize. I've forgotten, or I can't pronounce his last name, but his name is Tommy. And they brought him in and they said, Tommy, go into the building and pick up the 2 suitcases and bring it out to the station wagon. And so Tommy did. And then Walt Arnold, who is going to be responsible for putting it together in Nevada, he gives Tommy a .45 caliber, an Army pistol. And he says, here, guard those suitcases. Don't let anybody touch them. So Tommy says, yes, sir. And he sits there. And there's this precious picture of Tommy in the station wagon. And he's eating his lunch, his ham and cheese sandwich. And he's using the Clio as his lunch table. So, yep, that's improvisation and stranger than life. And they delivered it out to Nevada, and they put it together out there. In the same time, Harold Brown with his group at the Megaton Group, they worked on an extremely radical new way of making a secondary, that is a thermonuclear weapon, that it never, ever, there was nothing like it before, and they put it together. These are 2 audacious acts, because remember, if they fail, the laboratory for sure will be shut down. And yet they came up with 2 revolutionary devices that were small. And the reason they were small, I have it on my top point, those RAND analysts that I mentioned before, they were telling the physicists, unless your weapon is small, it's going to be irrelevant. We need weapons to be small to be survivable. Well, then they took it to be tested. Oops, sorry. And they worked. The Clio worked perfectly, exactly the way they predicted it would. It was the first success of the laboratory. Lawrence was so excited about it. He got out of bed from his colitis attack, came out to Nevada to get fully briefed on it. They were that excited about their first success. 2 weeks later, the Linda, the other device was called the Linda. That was tested. Lab physicists who knew it was going to be tested, they knew the morning it was going to be tested. And many of them drove up into the Altamont, and they could actually see a slight flash in the morning at the sunrise when they knew that the shot was supposed to go off, and they could see little remnants of their work being tested 500 miles away. But it worked perfectly. It worked exactly the way they said it would. And it finally, the onus was off of the young people working in Livermore to shut them down. Nobody was talking about shutting down the laboratory anymore. They'd shown how they had progressed into becoming professionals at this work. Because of the great success, then AEC then came and created Sandia Livermore. So Sandia Livermore starts, a guy named Bill Marsh arrives with about 6 or 8 people, and they start Sandia Livermore in one of the barracks buildings at the laboratory. And also that's the same year that they start Site 300, which is the high explosive site out in the Altamont, off on Corral Road. The continuation of Tesla, Coral Hollow Road. And that's where they do their high explosives testing to test the models that are going on. And that's a result of this 2 successes. Meanwhile, the laboratories are settling, the lab physicists are settling down. They formed a club, and they had a rally club. It was kind of like an orienteering thing. They would have all these map points, and they'd be racing around the Altamont and into Central Valley, picking up clues from each of these. And of course, they were inventing things in the back of the cars, and they had these crazy inventions that would help them to navigate. Usually the wives were doing the driving as I spoke to them. The wives would be the ones running these sports cars throughout the valley as they were hunting for all these clues. And life was settling down for the young people working out here. And they began to realize maybe they are going to have a permanent home out here. Another individual who got hired out here was a Greek. He was an American born in Boston, but his parents were born in Greece. And after Sputnik was launched in October 1957, he had a fear that the Soviet Union could use Sputnik kind of rockets to launch nuclear weapons into the United States. And he really feared for our safety. And so he came up with an idea how to stop that. And his idea was to launch a rocket up into the magnetosphere, which is above our atmosphere, and you detonate a nuclear weapon up there. And the nuclear weapon would then spread out electrons. One of the things nuclear weapons do is they emit tons and tons of electrons. And so he said, you do this, blow it up, and then that would create this blanket of electrons. And so if the Soviets tried to send a rocket into us, as the rocket went through the belt of electrons, it would destroy the bomb inside. It would destroy the rocket before it to re-enter the atmosphere and protect us. It was an early version of, frankly, what President Reagan would call the Strategic Defense Initiative, or the Star Wars of the 1980s. So back in the 1950s, Christophilus had this idea of doing the same thing. And the president's science advisor flew out to Livermore. They had a 3-day meeting. They went over everything. They said, this is a good idea. It could actually work. And so they created a program called the August program, in which they actually went over a remote island in the South Atlantic called Gough Island. It was a British island. And they launched 3 rockets. Then they detonated 3 small atom bombs. These were 1 or 2 kiloton bombs, about 300 miles above the atmosphere. They released the electrons. We had Pioneer satellites at the time going on, and they detected the electrons. They actually made the electrons, made the blanket. But the problem was the Earth's magnetic field was not strong enough to hold the electrons in place, and so they dissipated away. So it was a good idea. It just would not work on Earth. But in the meantime, Queen Federica of Greece found out about all the good work that this son of Greece was doing, and she decided to come out to Livermore to thank him. And then, so it was announced, and I've spoken, she was coming, and they were gonna have the teachers of our school system, we're gonna have all the children in our grammar schools come out on the streets along East Avenue and along her route, and they gave them little flags of Greece. And they said, well, and they told the children, well, the Queen of Greece is coming and we're gonna greet her. And the kids all wondering, why is there a Queen of Greece? Of course, they were thinking of like a frying pan, the grease in a frying pan. So the teachers had to go, no, it's not a frying pan Greece. It was actually a country named Greece. And they, oh, okay. And then they gave them Greek flags. And so everyone lined the streets, the kids lined the streets, and they all waved at the Queen going by. And you can see, that's a picture I took, snapped off a newspaper that caught a picture of the event. And that's a man named Sterling Colgate on the left. Nick Christophilus is in the middle, and Edward Teller is off to the right. And they're greeting the Queen of Greece at the entrance to the laboratory. And this all happened in 1958. Meanwhile, while this is all happening still, things are heating up in the Cold War, and Americans are getting concerned. The Russians have launched their Sputnik in October of '57, and President Eisenhower formed a committee. It was called the Gator Committee, and the Gator Committee did a study, and they came up with an alarming report that the Russians were building a massive nuclear strike force with their missiles. They were creating a lot more rockets than Sputnik. And a term grew up called the missile gap, in which the Russians were really building like heck to build up. And they were predicting that it would be possible for the Russians to then drop nuclear weapons on us without warning, without any kind of warning. There was no way we would ever know they were coming. And so for those of us kids who were in school in the late 1950s, we started going through all these air raid drills, in which part of the drill often, I know in my school we did it, we had to get underneath our school desks as part of our drills, and all those crazy things that were happening back then. It was kind of came out of this Gaither report. It scared quite a few people. And in Livermore, a movement grew to build fallout shelters because they figured, if the Russians are going to do something, they're going to come after Livermore with the laboratories. So quite a few residents in Livermore, and if you go back to the newspapers in those days, you'll see lots of articles on citizens building these fallout shelters. And one special one of the lab leaders, his name is Art Hutchins, he built a hefty, large, really large fallout shelter, and they showcased them in a newspaper article, and it had all the stuff, and Hutchins showing how you can fill it out and what you need and this, that, and other thing. So things were getting pretty tense, getting very serious at the time, and consideration that we might actually have a nuclear war with the Russians. In the meantime, now the next year, now 1956, back to my other story, we go back to test. Now we have the veterans. Now we had 2 successful tests, right? We tested the Clio, it worked. We tested the Linda, it worked. And with Brown's group, with the secondaries, they decided to leverage the design of the Linda into things. And Mike May, his first attempt, he developed a weapon that became the longest lasting weapon, high yield weapon, the highest yield weapon, and one of the longest lasting weapons in our stockpile, which protected us for decades. It's called a W41. But you see that picture on the right, the standard weapon at the time Mike was doing this, that's the B-17 bomb. if you remember that movie, or maybe you don't, Dr. Strangelove, but in the end, Slim Pickens, who, by the way, he was discovered because he was a rodeo. He actually was a rodeo cowboy, and he'd been discovered at the Castro Valley rodeo. Anyway, I'm digressing, but anyway, that bomb that he sits on at the end of the movie, that's the bomb, the B-17 bomb, which is dropped by that B-36 bomber. The Air Force had to invent a bomber big enough to carry one bomb, the B-17 bomb. And Mike May developed a weapon that outperformed that thing and was 1/4 the size. It was small enough that many other aircraft could be carrying it. The big implication being it was more survivable. It wasn't strictly located in these air bases which held these large bombers. Now you could hide it much more readily, and it was a big push forward for the Air Force. At the same time, they invented, this was important, they also tried out the Linda as a smaller size, and they called it the Flute. And that worked perfectly. It worked really well. And that thing weighed less than 1,000 pounds. Now, to give you an idea, that's about 3 to 4 times smaller than the smallest thermonuclear weapon that was deployed at the time. This thing was incredibly small, and it still worked. And at the same time that they were doing that, Johnny Foster's group were developing their own atomic devices that were becoming small, and that led to a thing called the Robin, which became a prototype for other kinds of atomic bombs. The Robin was so small you could hold it in your hands, and yet it gave the same kind of performance as you would see in the Nagasaki bomb. So it was phenomenal advances in making these things small. And at this time, there was a huge debate going on that Stalin had just passed, but they had Khrushchev now had taken over the Soviet Union, and they were threatening and basically threatening to invade Western Europe. Especially, they wanted to invade Germany, and first they wanted to occupy the capital, Berlin. And so it was clear a crisis was coming. And the chief of naval operations at the time, Admiral Ollie Burke, he became chief in 1955. He came up with an idea, well, rather than having these big, huge bombers where everybody knows where they are and you could secretly attack them, and Rand Corporation did a study that showed the Soviets could successfully destroy our thermonuclear weapons in one fell, and then we'd have nothing as a deterrent. There would be no way we could retaliate. And so our deterrent force was basically built on a hill of sand. And Burke was suggesting, why don't we launch our weapons from submerged submarines? You can't sneak attack them things. You don't know where they are. And they would be the ultimate survivable deterrent. The problem was to fit a missile inside a submarine, it had to be much smaller, which the Navy did, they developed it. But your thermonuclear weapon that went on it also had to be small. It had to be a lot smaller than these monsters they had. In fact, it had to be less than 1,000 pounds. And of course, we had just tested such a weapon. And so we did, I'm sorry, let me go back one. We did, and then we got a contract. At that conference, Edward Teller stood up and he said, Admiral Burke, we can give you a small thermonuclear weapon by 1961. Sorry, I don't think he sounded just like that, but it was something like that. And the Navy then, Admiral Burke gave a contract to Livermore to develop a warhead for this new fleet ballistic missile, which they called Polaris. And amazingly, within 2 years, the laboratory came up with a warhead for that thing. And this warhead was 3 to 4 times smaller than anything else that existed at the time. There was one Nobel laureate said it couldn't be done, and they did it. And so in January of 1960, they launched the first Polaris submarine. And then later here, you see that picture in the lower part where they're testing a Polaris missile to get. And so the laboratory made the deadline ahead of time. And now we had a deterrent structure that was very survivable, you could not destroy it. And 8 months later, Kennedy is elected president of the United States. And immediately Khrushchev determines he's going to test Kennedy. He thinks he can take him on. He's going to bully him. And they have a meeting in June of 61, just 5 months after Kennedy is inaugurated. They meet in Vienna. There's a picture. There's Khrushchev, bully, not Putin, that's Khrushchev. And he gives Kennedy an ultimatum. And he tells Kennedy, you pull all your troops out of Berlin in 6 months because the Red Army is going to occupy Berlin. And in these days, I guess we know what that's like, right? Except Putin telling Ukraine, I'm coming in. But this time, Khrushchev's telling Kennedy, get out, we're coming in. Kennedy is not going to budge. Kennedy, he respects Khrushchev is strong. They have a 5 million man army. He knows how strong he can be, and he could overwhelm our forces, but Kennedy is not going to give it in. And he faces up to Khrushchev and does not give an inch. Later, his security advisor, McGeorge Bundy, says it was the strength of America's nuclear forces. Kennedy admitted later that's what gave him the backbone to stand up to Khrushchev. And fortunately, we were prepared for that moment when we were doing it. Kennedy was not going to abandon 2.5 million Germans living in West Berlin to communism. He just stood up to him, and Khrushchev blinked, did not invade like he promised he was, and instead they built the Berlin Wall. That's why the Berlin Wall was built. It was built to stop East Berliners from escaping into West Berlin, and that occurred in 1961, and that ended the crisis. 6 months later, Kennedy reflected on how close the country had come to a thermonuclear war, and he decided to come out to Livermore to thank the physicist who had given him the Polaris warhead that gave him the backbone to stand up to him. So he comes out, and he announces, I'm going to come out, but there was not enough time to come to Livermore. So instead, they're going to meet the RAD lab, the mother laboratory in Berkeley. And so there's a picture there on the left of Kennedy. On the far left of the picture, that's Norris Bradbury, the head of Los Alamos, looking off in the distance. The other individuals all smiling, looking at the president. That's Johnny Foster. And next to him is Edwin McMillan and Glenn Seaborg, the discoverers of neptunium and plutonium that I discussed with you. There's the president, then Edward Teller, then Secretary of Defense McNamara, and there's Harold Brown on the far right. And they're all come, and Kennedy is paying homage to the Livermore Laboratory. He wants to thank them for avoiding a nuclear war. And so he moves over to the Berkeley Stadium, in which they had 85,000 people in there. And there he is on that platform. And he comes up with this sentence: I am forced to confront an uncomfortable truth. The new frontier, which is the name of his administration, may well owe more to Berkeley than to Harvard. And so there he is publicly thanking the physicists and the engineers of the Livermore Laboratory for averting a nuclear war. And before I failed to mention, right after that picture was taken, Kennedy turned around, he walked through those doors into the lobby, and Mike May, who I mentioned earlier, designed that bomb, he smiled, saw Mike May, smiled, walked up to him, shook his hand and said, thank you. And Mike told me later, I said, what was it like meeting President Kennedy? And Mike said, Tom, it was the proudest day of my life. And I knew I had to write this story for these guys who kept our society together and kept us protected throughout the Cold War. And that is all written up in this book, From Berkeley to Berlin, which Livermore Library has it. And I know it's busy, it's signed out at the moment. But I'm happy to announce the History Center at Carnegie Park. I think you guys know where the Carnegie Library building in Carnegie Park. They've ordered the books. They're going to be there very, very soon. And I'll be happy both the Historical Society and Guild, and a Library Guild can start arranging. We can have authors' nights, and I'll be happy to show up and sign the books and do whatever else is necessary. Whatever you'd like me to do, I can talk a little bit more, but I need to shut up now because I've been talking too much. And I'm going to, with that, I'm going to come back here and I'll await questions if anyone has any questions they'd like to ask.
Tom asked a question early on. He asked, how much did you rely on the LANL archives?
To do my research. Well, let's see. The early part, a lot of the stuff on the Manhattan Project. So for example, Hans Bethe, who is the head of the theoretical division at Los Alamos during the war, he wrote a daily journal. And I read every page of his journal. So throughout World War II, and how they slowly developed the atomic bomb. So I read that very carefully and learned a lot. And then there were a lot of things. Teller did all of his early work on the super at Los Alamos. And he wrote a famous paper with a Polish mathematician named Stanislaw Ulam. And I read that original document. That was written in March 1951, a year before the laboratory was created. And I read that document at least 5 times, trying to understand exactly what they had to say so I can understand their ideas. So I used Los Alamos archives for all of the things that happened before 1952. After 1952, pretty much all of what I have came out of the Livermore archives that we have at the laboratory, which were precious. There were thousands of pages of works in progress. For example, I asked Mike May how he came up with this idea that for that highly successful weapon he designed. And he told me, well, Johnny von Neumann came into one of our meetings and he said this and he inspired me. I actually went back and I found the minutes to that very same meeting. And I called up Mike. He came back to the laboratory and he sat in my office. And I got it up on my computer screen and I could see him smiling. And there it was. I had the exact minutes, the drawings and all that. So the Livermore Archives gave me everything after 52. Los Alamos gave me pretty much everything before 1952.
Great. Tom, I have a question for you. Maybe you'll know what the answer is. What about, as Mike said, what about the famous Einstein letter?
Okay, the behind that is Edward Teller in his memoirs relates how a man named Leo Szilard, who is a Hungarian-born physicist, he worked with Eugen Wigner and Edward Teller. They were all Hungarian Americans, and they were trying to wake up the government to the threat posed by Hitler having the atomic bomb. And so they wrote a letter. Wigner wrote half of it. Leo Szilard wrote the other half. And they put this letter together. And then they got in a car. Edward Teller was the chauffeur. And he drove out to Long Island. And he went to Einstein's summer home. They presented the letter to Einstein. And in it, it urged President Roosevelt to pursue a research on the atomic bomb. And Einstein signed it. And then they gave it to a friend who had access into President Roosevelt's office. And they did. And it took several months for him to get into it. But the thing is, from my research, when that letter arrived in Roosevelt's office, Roosevelt had already known about the atomic bomb. And of all things, he got it from a briefing given by Enrico Fermi when Fermi arrived in this country. And Fermi, excuse me, he went to the Pentagon and he gave a briefing to the head of research and development for the Navy. And the Navy was very interested in this new atomic power to power submarines. And the idea, the thing came up, this also could be a bomb. But at the time, Fermi said, well, he's not created a critical reactor yet, so he can't answer their question. They all wanted to know, well, can you make a reactor? Can this thing propel a submarine? Can you make a bomb out of this? And Fermi, being a good physicist, said, well, I haven't done it yet, so I can't say it can be done. And so they wrote that up, and being as they are, if Fermi said it hasn't been done yet, that means it can't be done. And so the letter went up to Roosevelt, and he was under the impression that they already knew about it, and the Navy decided it can't be done. So that letter was a little bit, in my opinion, overstated. It did not wake up the government at all. It certainly was renewed. It did provide a little more impetus to get going, because you had a man like Einstein now suggesting you should do it. But frankly, by that time, Roosevelt had already created a committee to study the problem. So I hope that answers your question.
Yes, looks like that's a good answer. So who's the father of the super, Ulam or Teller?
Well, they all are. Teller wrote a magazine article after this, and he said it's the work of many, many people, and that's true. Teller deserves credit for keeping the idea alive for years during World War II and at the end of World War II, for being the prominent promoter for pursuing the super. But frankly, Ulam gave that critical suggestion in a paper he wrote in 1950. And then he went and spoke with Teller, and the two of them together came up with an idea. And I explain it a lot more in my book. So I hate to keep saying that, but yeah, it's in my book a little bit more. But it's not either or. It's not Teller or Ulam. They both shared, they probably share the majority of credit for doing it, both themselves. And if I would put a percentage on it, I'd say maybe 60% goes to Teller, 40% to Ulam.
Great.
I have to see.
We've got another question from Tom. He wants to know, how much did Bradbury's foot dragging contribute to disinterest at LASL toward the super?
Well, Norris Bradbury supported research on a super. The President Truman ordered them to pursue the super. That he did that in January 1950. There had been resistance to working on doing thermonuclear research before then. John Manning, the deputy director at Los Alamos, actually wrote a letter to the Atomic Energy Commission telling them that he opposed any kind of research on thermonuclear weapon. But Bradbury did not stop it. And I wouldn't say he dragged his feet on it. On the other hand, though, he was not passionate about it. As he wrote later, he didn't feel the whole thing would be designed in his lifetime. Even it would, yeah, maybe this will come about. This is not something that's going to happen soon. And so he didn't put a lot of energy into it. He allowed it to go. He allowed he had a thermonuclear program put together, and they pursued it. So it's not as though he was foot dragging. I think the thing was he didn't treat it as a top priority item to go. And as a result, and Bradbury remained the director at Los Alamos for 25 years now. So he was, and I have to say, reading his papers in the 1950s, he sounds tired. He sounds like he was really much more interested in getting Los Alamos converted into a scientific laboratory. Remember, I showed you that acronym, LASSO, Los Alamos Scientific Laboratory, and he really wanted to emphasize a lot more scientific research, and that seemed to be where his passion was. So things forwarded, but Bradbury was a little more organized. His measure of merit, if you will, would be how many weapons got on the nuclear stockpile that had the name Los Alamos on it. And I think he was very proud of the fact that Los Alamos was providing the nation with its nuclear deterrent force. And one of the things he did not like about the Livermore being created was it was competition, and he was not a great one for competition. So did it hold it back? No, I think the biggest thing that got, in my opinion, the biggest thing that got Los Alamos accelerated and moving really rapidly was once the second laboratory is now going to be created and was going to pursue the same goals. And I think that really got things going. Now, remember, Los Alamos did detonate a hydrogen bomb in November of '52, just 2 or 3 months after Livermore was created. They had the Mike device go off, and that was based on the Edward Teller Stan Ulam idea. I mean, so Los Alamos was moving. They were definitely doing things, but I think it did spur them into high gear once Livermore got created.
Great. Were Swan and Robin TN devices?
No, they were atomic devices.
Okay. Now I have a lot of thank yous, lots of good, lots of very positive, good comments, and someone wanted to ask if there was going to be a book signing, and we'd love to do that at the Heritage Guild. And as Harry just said, we've ordered 60 copies of your book, and it should be here definitely by May 1st, hopefully sooner, and we can start getting the word out regarding that. So, here's one other question. How many of the folks featured in your book are still alive?
Let's see. Johnny Foster is quite alive and well. He's 99 years old. He's going to have his 100th birthday this coming September. Oh. He lives in Santa Barbara. Mike May is alive and well. I've traded emails with him. I trade emails with him regularly, and him and Johnny. He's living in San Francisco, and he still does work with Stanford University. Herb York, I'm sorry to say, died, and Harold Brown died 2 or 3 years ago, which was upsetting because it was Harold Brown who insisted that I had to write an unclassified history of the laboratory. And of course, I smiled when he said that, but then he called up the director of the laboratory and the next day. And so the next day I realized, I better write this book because Harold wants it written. So I was very sad to see him die. And then several of the others, I mentioned George Mention, who was a mentor to me. He was my first group leader. God bless him, but George died a couple of months ago, and I miss him dearly. But other big, Bill Grassberger is a big character in the book. Bill is very much alive. I believe he's 95 years old now, and he's living out in Oakdale. It's a few hours east of us. And the last time I went to visit him, he would get up first thing in the morning and go on a 1 or 2 mile walk every morning. So Bill looks still very healthy, very, very bright man. If any of you ever listened to my Wednesday afternoon lectures, I said Bill was basically the guy who put together, and which eventually would become Star Wars in the 1980s. And that was Bill Grassberger's work, him and another gentleman named Jim Schofield. Dick White, who worked with Sterling Colgate, is still alive. Well, he lives in an apartment on East Avenue right by East Avenue and Livermore Avenue, near the corner of East and Livermore. He looked pretty good the last time I remember interviewing him. So there are a few. In my book, I have about half a dozen more. Carl Hausman, some other guys who unfortunately they've passed away. But there's still a small handful of very brilliant individuals who worked here in the 1950s and did marvelous work for our society. And we have a lot to thank them for.
Yes.
Tom, someone's asking about the U.S. first tested an H-bomb near the Bikini Atoll in November '52.
Correct.
Where was that experimental bomb constructed, and what was the impact of that successful test?
Okay, that's correct. It was November 1st. Trying to do the date line. It was either October 31st here or November 1st. It was over the date line. But anyway, you're right. It's epic. It was in Eniwetok. Actually, it was in the Marshall Islands, in the Eniwetok Atoll, and it was a 10 megaton device, and it was a total verification of the Teller Ulam paper that had been written in March of 1951. And so the whole idea that you could take the heat from an atomic bomb and translate that into thermonuclear energy was proven to work quite well. That was Fermi's original question that Fermi had asked back in 1943. Its implication was, well, it certainly put us, we were the first ones, but this is important. 6 months later, just 6 months later, the Russians detonated their own H-bomb. So it was extremely clear all the while. I know Oppenheimer had always been arguing that we shouldn't be doing thermonuclear research because that would cause the Russians to start thermonuclear research. As it turned out, the Russians started ahead of us. They were ahead of us by a couple of years. And but we were able to develop an H-bomb before them. But 6 months later, what the intelligence community called Joe 4, their fourth nuclear test, was an H-bomb. The Russians had created a thermonuclear center at the Russian, it's called FION, it's a Russian science center. And in, I think, 1946, they hired a really young physicist named Sakharov to work with them. And so significance was the Russians did not have an H-bomb all on their own, that by the time the Russians detonated their H-bomb, we already had one. And that later gave emphasis that the Russians then wanted our research to stop because we were ahead of them. And so in 1958, they came up with a strong initiative to stop nuclear testing. Everyone stopped nuclear testing. Khrushchev presented that to President Eisenhower. And Eisenhower, he thought it was a gimmick at first, but eventually came around. And so we entered a test ban in 1958. And then in 1961, the Russians suddenly they reversed themselves. And they conducted 45 nuclear tests in a matter of 30 days, including one test that was 60 megatons, the so-called Tsar bomber up in Novotsemaya, up near the North Pole. So its significance was that it kept us ahead of the Russians so that they did not have a hydrogen bomb all by themselves.
And we have another question. Did Khrushchev know what weapons Kennedy had at his disposal when they faced off over Berlin?
Yes, I think he certainly Russian intelligence was such. They were certainly aware we had launched Polaris submarines and that we were capable of launching missiles because we had these missile tests. And there were pictures of Kennedy observing these missile tests. So I'm sure the Russians were aware that we had developed a missile that could be launched from a submerged submarine. What they may not have known was that the United States could develop a warhead for that. Because as I mentioned in my talk, there was even a Nobel laureate said it's impossible to make a warhead that small that could fit in such a small missile. You can't do it. The smallest warhead we had was over 1.5 tons. And in order to fit inside these little missiles, relatively little missiles in a submarine, the thing had to be 1/4 that size. And the idea is now that that's way beyond our capabilities. And so, but once we start deploying them, I'm sure if Khrushchev then asked his experts, they would say, well, the Americans have deployed 10 Polaris submarines in the Arctic Ocean. And we have to assume each one had 16 missiles in it. We have to assume that they're capable of doing that. So I think maybe in Vienna, Khrushchev may not have been aware of how strong our force was, but I'm absolutely certain when he got back to Moscow after that summit meeting, that his experts told him, no, they have the capability of destroying us and there's nothing we can do about it.
Great. I think, do you have any more questions, Blanche? I think that was.
There's one. When did the lab get named for Ernest Lawrence?
It was named after Lawrence in 1958. Lawrence died in, he was 57 years old, and he died from colitis, from his so many colitis attacks. He died in 58. And so the regents of the University of California renamed the RAD lab from the University of California Radiation Lab to the Lawrence Radiation Lab. So both the laboratory in Berkeley and the laboratory in Livermore changed the names to the Lawrence Radiation Laboratory. Then in the late 1970s, a formal split was made, and then you had the Lawrence Berkeley Laboratory and the Lawrence Livermore Laboratory, and then they became distinctly two different laboratories. But before that time, it was all one laboratory, and we were all the Lawrence Radiation Laboratory. So it started in 58. Oh, within weeks of after Lawrence had died, it was renamed after Lawrence. And the Lawrence Radiation Laboratory remained the name for about 10 years, or 10 or 15 years, until there was a formal separation, and then it became Lawrence Livermore Laboratory. And then in the mid-1980s, with all the massive demonstrations occurring, and some group had gotten Lawrence's widow, and to have her sign a document that she opposed the Livermore Laboratory being named after her husband. And that's when the Department of Energy came in. So this is a national, this is not a state organ, this is a national organ. And they changed the name to Lawrence Livermore National Laboratory. So that was the latest change in name.
Okay, I think there's one more question here. This one could probably be a talk by itself, but see if we can give you an answer here. Did espionage contribute to the Soviet thermonuclear device?
I'm sorry, did SDI, the Strategic Defense Initiative?
Yeah, I think, yeah, oops, the question's gone. It just says
it was espionage.
Espionage.
Oh.
Did espionage contribute?
Oh, yes, for sure. In when was that? Around 1951, 52, they discovered 30 workers at the Chicago Metallurgical Laboratory, which was one of the Manhattan Project laboratories. 30 Canadians that were working there turned out to be Soviet spies. There were a handful of spies working at Los Alamos. The most famous was Klaus Fuchs. And Klaus Fuchs gave the exact plans of the Trinity device back to the Russians. And when the Russians detonated their device in August 49, it was an exact replica of the American bomb. So that was all espionage early on. Also, Klaus Fuchs, he was at a conference at Los Alamos in 1946 that discussed the super. Teller ran the meetings, and he actually got a patent on the hydrogen bomb with Johnny von Neumann. The two of them co-wrote a patent and got a patent for the hydrogen bomb. And Klaus Fuchs was a Soviet spy. And so, yes, the Soviets had the complete thinking of the United States on how to make a hydrogen bomb right from the get-go. And a lot of it, if not all of it, was based on espionage. Now, having said that, people like Sakharov, who are, the physicist in Russia, they were not dumb. And they had their own ideas, and I have no doubt the Russians would have still, within 4 or 5 years, been able to develop a hydrogen bomb on their own. But they did have a lot of espionage help.
We've had some questions about whether the presentation will be available online, and it was recorded tonight, so it will be posted to the library's YouTube channel. And I think the Heritage Guild will also post that link.
Yes.
So that should be available by the end of the week for anybody who wants to watch it.
Yes, and I have to agree with the last person. It was a fantastic presentation. Thank you so much, Tom.
Well, you're most welcome.
It was wonderful. Thank you for sharing all that history, that very high stakes Cold War era story that was Livermore right at the heart of it, with all the scientists being heroes. It's wonderful to hear that. And I want to thank you all for coming.
Yes. Yes, thanks very much. So we'll let you go now, Tom, but thank you so much. That was a great presentation.
Thank you so much.
And
Okay.
And I'm sure more people are putting holds on your book as we're speaking right now.
Fine.
But I say we can they will be available for purchase at the Heritage Guild bookstore. We will have them and definitely by May 1st, and if not sooner.
Wonderful. Okay, I'm signing off now.
Thank you, Tom. Good
Bye-bye.
night. Thanks, everybody.
Good night, everyone. Thanks for joining.